So this particular problem was in the homework. This was, I guess, 6.1, if that's
Mhm.
right. And so this was taking a fraction into a percent. My guess, and it sounds like some of the answers that people tried should have worked. I can actually look to see, what the official answer was. But I don't know if you remember my table, fraction, decimal,
Mhm.
percent. Sometimes when you have a fraction, the easiest way to go is to first make it a decimal and then make it a percent. And so I'm going to try it that way first. So to make 5 6 into a decimal, this is 5 divided by 6. Remember, 6 is going to be on the outside and the 5 will be here, meaning that you're going to have to add a couple zeros to make this work. 6 into 50 looks like 8. 8 times 6, 48. Subtract 2. 6 into 20 would be 3. This is 18. And you probably can guess that it's going to keep on doing this. So what we have left is a remainder of 2 divided by 6. And 2 divided by 6 is actually 1/3, right? And so this is one answer. So to make, this is the decimal answer. And so to make it a percent, if you recall, you're going this way, you go 2 to the right, which is that way, 2 to the right. So the decimal has to come over 2. That's why I stopped at 2 decimal places. So by bringing it over 2, this would be 83 1/3%. Now, if I was doing it, that's the answer I'd enter, but that doesn't mean they liked it. Did they or didn't they?
I didn't type it in exactly like that. I did 83 and it was wrong, and then I did 83.33 and a third, and that was wrong as well.
Yeah, I think they were confused about the 3 3 1/3, which
Mhm.
is technically right. Um, the reason I stopped after 2 decimal places is because I knew I was going to have to shift it to,
Mhm.
so that I wanted it to end there.
Okay.
Then the remainder, 2 out of 6 divided by 2 out of 6 became 1/3. So I intentionally, now I knew what I was doing, but I was intentionally just going out 2 places so that the decimal actually ended up here after the 3, and between the 3 and the 1/3. That's my guess. I don't know if anybody tried that answer. Tell me what problem it was, and I'll, look at several people's work.
It was
But
number 16.
number 16, okay. I'll definitely look at that. But that's my best guess about what they would like.
Mhm.
And the reason is if you had just put like 83.3, you've actually rounded it and threw away a portion of this
Mhm.
answer, because
Mhm.
this answer is 3 forever.
Yeah.
And so this is exact and nothing has been thrown away. So it's my guess that this is what they would like.
Okay.
Mhm. Let's give it a try. Did somebody have something else?
Thank you.
Okay, good. Yeah, that's my best guess. And I will look carefully to see if what they're asking for. The one thing I wanted to do last class, what I did was I showed you how to take a simple sentence that's about percents and turn it into an equation by translating every little bit and then solving. And there's no waste here, because what you're going to eventually do, of course, is to learn some algebra. And so it doesn't hurt to use a little bit of it at this point in time. But what I wanted to do is show you another way. 7 is what percent of 10? Okay. Now, the way I did it was I translated it. 7 equals the what percent became X or N times 10, and then we solved. But what I want to show you now is what was at the end of 6.2. It was a second way to do it. You could ignore me, because if you don't want to have two ways, then that's fine. But the other approach is using a proportion. And what happens is on one side is always the percent. So in this case, we don't know the percent, but this spot here is always 100. So it's, if you have this number, like if it was 15 or something, that would be 15%. Now, what happens on the other side is this is the part, and the second one is the total. And the trick is to try to decide which is which. So I've got the number 7 and the number 10 to place in these two places, these two positions. Now, there's one good thing that will help you in these problems, and it's this. After the word of, you always have the total. What does that mean? That means that the total is 10, which by default means the 7 is the part. So it's really 7 over 10 is what they're talking about. They want to know the percent. Once you've completely put this into a proportion, you have 3 out of 4 numbers, you solve. So this is 7 times 100 would be 700. And 10 times X would be 10 times X. And at this point in time, you want X, that's what you wanted. And so you would divide both sides by 10. X equals, okay? So 10 over 10 is 1. We do this all the time. And so this is my answer, but I'm going to take out one pair of zeros. And what I have, 70 over 1 is 70. Now, here's what this means. The X here is 70. So the answer to this problem, what is the percent? It would be 70%. So the trick is, this is always 100. This would be the percent if you had it. This would be the total, which is always after the word of, and this would be the part. I'm going to do one more and then go from there. 12 is 20% of what number? Okay, with this approach, and if I'm showing it partly because somebody may have learned it this way. The first thing I see is the 20%. So I can do that straight off the bat. The word of is here. It could be in either part of the sentence, but it's there. And this is my X or my N. It's following the word of. So this is the total. So I've got to put X here, which means process of elimination, the 12 is the part, and that had to be there. This is now set up to find the total. And so again, you just cross multiply. 12 times 100 is 1200 equals X times 20 would be 20X. At this point in time, I'm going to divide by 20 because that's what I want, is to get it down to X. This is actually 1X, which is X. And over here, I'm going to take out a pair of zeros. So 2 into 120, 60. So the correct answer for the total would have been 60. Let me put it here. The total would have been 60. And so that was the answer to that. This is not impossible to follow this approach. I kind of like the other approach slightly better, but this isn't bad. It's totally doable. Now, what they did in the third and fourth section of chapter 6 is to talk about doing applications of problems. And so let's see what they actually have here. Okay, here's an example. How much hydrochloric acid is in a 60 milliliter bottle? That is marked 80% hydrochloric acid. Okay. This I found somewhere in the book. The bottle is 60 milliliters. You know, with certain medicines, it's not 100%, it's a certain percentage. And so this particular one is 80% hydrochloric acid. So the question was, how much would it be? Now the question is, can you turn this into a simple sentence like we saw before? And this, of course, is the total. This is the full size of the bottle. And so what is 80% of the 60 milliliters? So the 60 is the total. We want 80% of that based on the question. And so two ways to do it, obviously, what N is equals 80% needs to be converted to either a fraction or a decimal. I'm going to make a decimal. Of is times. And so it's simply a matter of multiplying these two numbers. So this would be 60 times 0.80. And that's 1, 2. Okay. So it may help if you had seen the problem. Let me try and find a few more. Okay. I think we can do test scores. That would be good. An engineering student answered 81 questions correctly on a 90 question trigonometry test. What percentage did they answer correctly? What percentage did they answer incorrectly? Okay, did it matter that it was trig? No. Do these numbers matter? Yes. So we're interested in 81 correct out of a total of 90 questions. We want to know the percent. And so I don't know if this is going to come out fairly well or not. Maybe it will. So as a sentence, 81 is what percent of 90? Notice 90, even with the instruction we had here, after the word of is 90. 90 is the total. I mean, it's really this, 81 out of 90. And so turning that into a percent, I'm going to try it with my sentence. This is 81 equals what percent of 90? And the sentence basically forces us to do what we kind of had figured out already. To solve for x, I'd have to divide both sides by 90. And 90 over 90 is 1. So the problem in this case boils down to 81 over 90. And the interesting thing is this reduces. So I think I'll reduce it first because I really want to. 9 into 81 is 9. And 9 into 90 is 10. So this is a nice fraction, but they actually wanted the percent. And so I've got to deal with 9/10. You may be able to see that it's going to be 90%, which it's going to be. One way you could do it is divide it out so that you could see the decimal. 10 into 90 is 9. 10 into the 0 is 0. And so the decimal version of 9/10 is 0.90. And the reason I went 2 places again is because I know I need to shift it 2 places, and that person scored 90% on the test. Now, at certain points, you might have said, oh, I had figured that out a long time ago. And so just to be fair here, if you could clearly see that 81/90 was the real essence of this problem, you could have done this way. This basically says this is the part that the person got right out of the total. And then we could turn it into a percent, and you could cross multiply. And again, you're going to get 90%. So I don't know which one appeals to you more, but that definitely is what they're after. All kinds of problems of that nature. There's basketball. If a person had 63 out of, 75? So this is basketball, so it's about free throws, so they got to try to hit the basket. What percent are they getting in the basket? Same problem, it's just basketball, who cares? 63 is what percent of 75? Okay, and so I think you'd be able to do that. I'm always looking for a way to reduce this. You know what this is going to end up? It's going to end up 63/75 to see the percentage. So what percent is X of is times 75 is 75. And so in the end, this equation keeps you on track so that you're seeing this correctly. The word of signals the number that's on the bottom, and we've seen this before. The number on the bottom is the total. I want to reduce this. I want to reduce it a little just because I like smaller numbers. I'm pretty sure this would divide by 3. I can see the 6 and the 3. I'm also seeing 75 is 3 times 25. So I'm thinking I could reduce it by 3. You may or may not want to. 3 into this, 3 into 63 is 2, 1. Excuse me. Now, you do it. Tell me the percent. I'm going to cough a little bit.
Bless you.
Yeah, go ahead and get a percent. And I'll have a drink. Anybody get anything?
Is it 84?
I think so. Anybody have a different answer?
I thought we were reducing, so I see 3/5.
Oh, now what did you divide both sides by? when you divide, you're going to have to divide by the same number.
Oh, okay.
And so that won't work.
Oh, okay.
I want to remind you of something I did in the other class, or maybe it was last class or Monday, I don't know. 21 out of 25. I love the number 25. Why? Because 25 goes nicely into 100, which would give me my percent. So this is a shortcut, but I want, occasionally people catch it. And so 25 times 4 is 100. So we multiply both by 4 and look at what happens. 21 times 4 is 84. So what we have here is 84%. Now, could you do it the other way? Yes, you could divide it out and move your decimal, and sometimes you have no choice. This just happened to be a shortcut because 25 went perfectly into 100. How's that? Okay, that's good. That's very good.
Yeah.
Thank you. Question?
Mhm.
Okay, farming problem. Okay, here we go. A farmer owns 28 acres. Okay. On the 28 acres, only 65% can be farmed. So how many acres are available for farming? And what I forgot to do on the other one, and how many are not? So do we have a sense of this problem? Sometimes I like to draw a picture. Here's my 28 acres. More than half of it will be farmed and the rest not. So you can see what we're trying to do. We're trying to find a certain percentage of the total. Now I'm seeing the total is 28. That's what they told me. 28 acres was the total. And so if I made a sentence, it would be, what is 65% of the total 28 acres? And so this is X is 0.65 times 28. And so you just multiply that out and you're good to go. And I don't know, see if you, this is an 8, 0. Well, that's 2 decimal places. I'm getting 18.2. Now, if that's not correct, let me know. 4, 48, 52. Looks kind of correct. What do you think? Go for it. So, assuming that I can multiply, which sometimes is the truth and sometimes not, but let's say I could, then 18.2 acres can be farmed. Now, how would you get the rest? You have 2 ways, really, don't you? One way is to do 35% of the total, because that would 65 and 35 would be the whole thing. But probably the easier way to do it is to subtract 28 minus 18.2. I think that would be a little bit easier, don't you think? And so I need to borrow. This is an 8. This is a 7. I'm getting 9.8. You want to make sure that this one and this one add to 28. Looks like it does. And so your answer would be 18.2 acres could be farmed, 9.8 could not. And that would be your answer. Okay. So really, it's just a matter of can you visualize the problem that they're asking? Here's one about population. In a city of 32,000 people, there are 10,000 that are under 25 years old. What percent of the population under 25? Is that an okay? So I read it to you, but basically 32,000 was the total in the city. 10,000 of them were under 25. So the question is, what percent are under 25? Would anybody like to try making a sentence out of that? Simple sentence, so that we can translate it. Would you prefer to do this as a proportion? Would that make it easier? Is it clear that 32 is the total? Maybe we should. I'm not opposed to that method. We don't have the percent. So this side is filled out. Can you determine where the 10 goes and where the 32,000 goes? In other words, which one is the total and which one is the part? And it seems,
Well, the total is 32,000.
yeah, let's put it where it belongs, which means the 10, and that makes sense, I think. It's the 10,000 compared to the 32,000. Look at all those zeros. Guess what I'm going to do? 3, 3. Like that little problem better? I do.
Yes.
So you can't cancel anything across, but within the same fraction like that, you can cancel it. And I would. So the problem is now 10 over 32 equals x over 100. And so I'm going to multiply this way. 10 times 100 is 1,000. And 32 times x is 32x. I don't think this is going to come out even, so I'm just going to proceed cautiously optimistic, you know what I mean? So I divide both sides by 32 so that I can get x alone. And this becomes, if I can sort this out and make a simple answer out of it, I've got it. So it's 32 into 1,000. So let me see if I can't do that. So it's 32 into 1,000. So that's exactly what it was. 1,000 divided by 32. 32 is on the outside, 1,000 is on the inside. I'm going to do this. 32 into 100 looks like 3. 3 times 2 is 6. 3 times 3 is 9. Just fit. When I subtract, I get 4. I bring down the 0. 32 into 40 goes once. This is 32. And it leaves me with 8. Now I'm trying to decide what I need to do. This is going to be a percent already. So it's 31 and some change, 31%. If I stopped it there, it would be 8 over 32. And this is already a percent. 8 over 32 actually reduces by 8. 8 into 8 once, 8 into 32 4 times. 31.25%. It kind of depends on if they encourage you to make it into a decimal. which would have been 31.25, or maybe this would have been, they would have allowed that answer. Probably this would have been fine. So because of the original setup of this problem, when you solve for X, it's already a percent. You don't have to do any sliding of decimal points. And so we went ahead, and that's 31.25. So does anybody have any feeling about these two approaches? In other words, did this appeal? I suppose that's why they showed it both ways. This proportion way. Or am I just adding to the confusion?
I like the proportion myself.
I think it kind of worked. It sort of fit very nicely. It's really, this side is all, you know, the percent over 100. If you can identify the total, of course I wrote it in, but I think it was clear from the beginning that 32,000 was the total. Then all the numbers have their place. Let's try another one. Maybe this is good. We just want to make it work. Okay, distracted driving. The National Safety Council has estimated that approximately 24% of motor crashes involve cell phones. I don't know when that was written, but let's just say that's correct. In a study of 500 accidents, how many would be, and how many of these accidents involve cell phones? So how many had cell phones? Okay, is it clear what the problem is? So let's give it a shot. Let's try this. Do we have the percent? Yes.
24%.
So I'm going to put it in 24 over 100 and not worry about it. Now, the only other number I have is 500. Would you consider it that the part or the total? Your choice.
500 is the total.
It is the total. So this is X or N. See, this is where you say, did I do this right? I got the 24 over 100. I decided there were 500 accidents. How many of them were cell phones? I'm ready to roll. And so I'm going to go ahead and cross multiply. X times 100, I would write as 100X. This is 24 times 500. 500 times 24, 0, 0, 20, 0, 0, 10. 12,000. Zero, 0, 20, 0, 0, 10. Okay, I'm satisfied with that 12,000. The only thing I have left to do is divide by 100. I divide by 100. You get used to this little step. It's a good step. And so this is X. And then the 2 zeros here and 2 zeros here can hit the dust, and you're left with X is 120. So what they're saying is 120 of those 500 accidents involve cell phones. Does that make sense? Does that seem about right, number-wise?
Looks good.
Looks good to me. I think maybe we'll just kind of go with this if that suits you. Okay. So what I wanted to do, is look at 6.4, and it's titled, let me see, there it is. It's titled Sales Tax and Commission. Well, we know about sales tax in Seattle, around 10%. I remember seeing I was going to buy something and they had the sale was 10% off. You know where this is going. So they took 10% off and then they applied the tax and I was back where I was, but I guess that was better than nothing, right?
Exactly.
Anyway, so let me see, I've got a problem here. So this is Mississippi. Oh, I don't care. 7% is the sales tax. And if the price of a refrigerator was $550, it's used, how much is the tax? Is it clear about the problem? And if you want to draw a picture, here's my refrigerator, $550. And to that, I've got to add the tax, don't I?
Definitely.
And so it's going to be more. And so if you get less, you didn't do it right. But let's see what we can do about this. It's 7%, so drop that in, piece of cake, right? What goes here?
550.
Correct. I'll use N just to show you I can do it. Well, I want, now in a sentence, it would be, what is 7% of 550? But let's see, let's take this approach. This is N times 100, which I will always turn that around to have the number first and the letter second. This is common. This is 7 times 550, 35, carry 3, 30, let's call it 38, 0, 5, 3, why not? I had to learn math without a calculator. You might consider it a handicap, but it actually is it's a help. Now what? I'm going to divide by 100 and I'm going to divide by 100. Cancel, cancel, N. Now, dividing by 100 is actually a decimal shift. Do you remember that? When you divided by 10, you would move the decimal one place to the left. When you divide by 100, you move the decimal 2 places to the left. I could kill a pair of zeros. I could do that. But right now, dividing by 100, 3850, the decimal is here. When I see that my problem is to divide by 100, I'm just going to divide by 100. This is 38.50. What is this? This is the tax. Now, if you didn't move the decimal, the tax is 3,850. I think I'm not going to buy that refrigerator. You have to see, does that make sense? 38.50. It's a high amount, but it's still fairly close. What do you think? So the question, if they wanted to know the tax, then you would have to say 38.50. Now, what if they said, oh, now I want to know the full price? The refrigerator, well, I'm just telling you what to do, plus the tax. Then what do?
So you add them together.
Add them together. So it's 5, whatever it is. You can add them together, okay? So, so watch the question carefully. Did they want the tax? You give them that. Did they want the price, the full price, tax included? You would have to add it together. How is that?
Right.
Okay. Now, let's see. Oh, here's a cute one. Oh, I don't like the numbers. I may need my calculator, but I'm going to do it anyway. Suppose the purchase price of a stereo system is $396. That's the price. And the tax is what, $19.80. You know what they're gonna do? What's the tax rate? In other words, is it 5%? Is it 10%? Is it 7%? Mississippi, whatever. Is this possible to figure this out? Well, and when these numbers get so annoying, I sometimes pull out my calculator, but nevertheless, setting it up is probably the most important thing. We do not know the tax rate, which is the percent. So this is X over 100. Where do we put 396?
Denominator.
Correct. That's the total. The part, which was the tax applied, was 1980. It isn't always the smaller number. You've got to be careful, but in this case it is. So then you would proceed. This is correct. So if I'm looking at your work and I see you've gotten this far, you're halfway there. And as far as I'm concerned, that's 50% of your grade is right here. Now I want to see if you know what to do with it. It's a proportion. You cross multiply. That stupid product of means is product of the extremes. Who cares? 1980 times 100. When you multiply by 100, your decimal shifts to the right, making it larger. Is that clear? This is useful.
Yes.
I want you to do it this way. I don't want you to make a fuss about this because this is the safest thing to do. 1, 2. So this would be 1980 equals this product, which is 396 times X. I'm gonna divide. I want X alone, so I divide by 396. Both sides. There's fair. Cancel, cancel, X. So if somehow you can sort that out, you've got it. I know tricks. I want to reduce that thing before I do the division, but I don't have to. I'm going to try dividing it now. Both numerator and denominator divide by 9, by the way. This denominator is 9 plus 3 and 6 is 9. That's 18. It divides by 9. This one here is also 18. It divides by 9. So it could have been reduced, but let's see how much trouble we get into. This is almost 400. This is almost 2,000. 4 into 20. 396 times 5. 396 times, what did I think it was, 5? That was my first guess. 5 times 6 is 30, carry a 3. 5 times 9 is 45, and 3 is 48. Ooh. 5 times 3 is 15, and that is 19. I didn't like it, but it came out nice. This is 5, and what does that mean? When we go back to the problem, X is 5, which translates, the tax on this was 5%. Okay? Now, like I said, I could have reduced this fraction. It wasn't that bad, but I could have reduced it, making the division smaller numbers, which would have been easier. But nevertheless, this is 5. Now let's pretend for just 1 second that you cared. Get it? Do you
Yes.
care? That was a joke. So let's pretend you care. Let's pretend it's your money. $396 was the original price times 5%. 5 times 6 is 30, carry a 3. 5 times 9 is 45, and 3 is 48. 3 times 5 is 15, and 4 is 19. 1, 2. Was that the original tax? Yes. This is that one step. You know, when you have something you have that feeling that either you did something wrong or the person, you know, telling you how much you have to pay is wrong, check it out. You've got 5% as your answer. This confirms it. And so sweating over this problem anymore is worthless because you convinced yourself that that was the correct answer. So you know 5% is correct, and so you're good to go. What do you think?
That's
Did you
good.
care? And sometimes if it was your money, you would, wouldn't you?
Of course.
Of course you would. Thank you. Thank you. Thank you for agreeing with me so nicely. Now,
Miss Patterson,
yes.
I actually sent you an equation in the chat box. I don't know if you
Okay.
received it or not.
Yeah, I can't see it. Let me see if I can chat. I'm going to stop sharing for a second. Maybe I can see it. Okay. Totals, okay. The sales tax is I'm going to write this down. Everybody write it down. 6.75%. And the tax was $11.85. What's the purchase price? Oh, this is beautiful. That's well timed. Okay, I'm going back. Okay, I got it. Okay, so this is slightly different, but honestly, the proportion I think would work nicely. So here's what we have. We know the sales tax is 6.75. We know the tax was $11.85, and what we don't know is the purchase price. The minute you see the percentage, drop it in like that. Okay, done. The purchase price is missing. Where does 1185 go? Is it the
The
total?
numerator.
Yes, indeed. Was there enough there that did I write enough down to explain the problem? This was the tax. So this is the part. The tax shouldn't be more than the total here. And so this was actually the purchase price. So at this point in time, this is a good system. This served us well. I'm going to do this again. This is 1185 times 100. I hope you know that what I'm going to do is move the decimal 2 places, 1185. I'm going to go this way, which is 6.75 multiplied by X. And now it's perfectly set up. I've got the proportion right. I've got the equation right. I've got this. I'm going to divide by 6.75. Cancel, cancel, X equals. So if I can somehow sort this out, I will have it. So that's what I'm going to do. It's just pure division. I'm not opposed to a calculator at this point. But that's what the problem amounts to. And because the decimal is here, we don't divide by a number with a decimal inside it. So we're gonna have to move this over 2 places, which is actually multiplying by 100. I'm gonna have to move this over 2 places to be fair. And my decimal is now here. And I'm hoping I can do this without a lot of sweat. 675 into 1100. It's actually not 1, it's not 2, it's actually just 1. 675. This is 0. 8 take away 7 is 1, and this is 5. We know this is correct because this number is smaller than that number. I'm going to pull down my first 0. Oh, it's got to be a fairly good sized number. What is it? Anybody guess? Let's say 700. 7 into 50. 7 times? I'm thinking 7. 5 carry a 3. 49 and 3 is 52. 32, 42, 47. Yeah, I think it's a 5. I think it's a. So you would sweat through this problem. 4, 7, 2, 5. Subtract. Very good one. And bring down that last one. I think it's 5. No, I don't know. What is it? Have I made a mistake? Where's my calculator? If you have a calculator, feel free to use it. 1185 divided by 6.75. Oh, it was a 5. And then it's like a 5 repeating. So the question is, what kind of answer would they expect you to put down? We don't have money that goes like this. So what I think we should do is round it. And so could we round? This was money. So what would make sense? 175.55, 175.56. What is your choice? And this is money.
175.56.
I would go with this one, yeah. And they asked you for the price. So even though this kept on going, and I double checked it with my calculator just to be sure, but that's what I would do. Okay, so some of these answers don't come out nicely, and so and doing every little thing by hand is not necessarily what we need to do. But nevertheless, there's the problem. Okay. All right. There was, let's see, how's our time? Our time's on the test. There were a couple of questions that people missed. And so I wanted to just show you 1 or 2 things. One had to do, let's see if I can find it, with it was reducing. And a lot of people told me the ratio was 1 to 1. But the truth of the matter is, with this a decimal, they need to be both whole numbers. And so literally what needed to happen was this needed to be multiplied by 10 and this one as well. So the problem became 50 divided by 5. So the ratio is actually 10 to 1. Okay, that was one error I noticed on several tests on the last one. The other one had to do with this. When you had, it was orange juice or something like that, we had to find the unit price. And so what you did was you found, let's say the answer turned out to be like this. And so you divided it out and you realized this is what it cost for 1 ounce. But the problem was they wanted the answer in cents. So if you put 0.23, you're telling me that it's not even a penny. And it's more than a penny, it's 23 cents. And so literally, when they forced you to say, well, how many cents is it? The decimal comes over to here and it's 23 cents. This is in dollars. And so this is the correct answer in dollars, but in cents, it would just have been 23. I only took off a tiny little bit for that, but I wanted to mention that this is in dollars, this is in cents, and there's a decimal shift of 2 places to get from one to the other. Okay, well, let's see, I heard several people exit stage left. So what I'll do, I'm going to stop for now. Let me stop it.
Miss Patterson, can I ask